We're going to be using this setup here to launch a marble from the launcher set in this block here at different heights, different angles, to determine from this initial lower slot at 0 degrees how far theoretically should the ball go from the higher slot, 20 centimeters up at 0 degrees, and then how far the ball should go in the x direction from the 45 degree slot at this higher height. And you will launch the marble onto the floor, onto carbon paper that will transfer the impact to the white paper, from which you can measure the distance back up to the launcher, right? And so you can use each of these launchers are set to have the position noted as to where you should pull back the piston to. What you can do when it's in the launcher, it just slides in. We're pulling it back to this first slot. You're going to take the marble, in this case the orange one for the white. You're going to then take these launching arms, or the release arms here. You're going to slide it under the horizontal part of the piston, and then you can just let the ball go. It comes over, impacts the carbon paper on your white paper, and it'll transfer a mark on there. Just make sure to tape the paper down to the floor so it doesn't move around. You can let the carbon paper sit just on top of the white paper, and then when you're done doing your experiment, you can bring all the carbon paper back to the big pile so that it can be reused for future labs. And then one other note, when launching from the 45 degree angle, you can again set it to the given notch, and then we have a more curvy release mechanism to be able to get around the whole block here and still get in, and then you can still pull and release without severely impacting the launch itself. Say if you were to push, right, then your finger might get caught and decrease the distance artificially of how far the ball would actually travel. An additional note is that you want to make sure that the marble is pushed the entire way back against the piston, so that when you're releasing the piston, it is merely pushing against the ball rather than smacking into the ball, akin to a golf club smacking into a golf ball and just shooting it straight into the wall. This will just be a lot more consistent, ensuring that the ball is only being pushed rather than hit by the piston. To figure out where you should start your X position, you can use these plumb bobs to translate the horizontal position of the marble to the floor by taking the string and lining it up effectively with the center of the marble itself at rest, and then tracking how the plumb bob hangs down there. You can set your ruler to wherever its position on the floor is, so that you can then, once the ruler is straight, you could measure to the center of the scatter for each of the 3 experiments the X distance for those experiments. After each launch, you want to come over and mark where the ball had actually landed, so that after you get your entire set of 20 launches, you can then come over. You can estimate by drawing a circle or ellipse around your scatter shot, so then you can then estimate roughly where your center distance, your center of your scatter of your data is, and then you can figure out your X distance from the launcher, and then you can estimate your uncertainty based on the size of this circle that you've drawn. With the uncertainty that you've drawn, you effectively end up with some distance X plus or minus your uncertainty delta X.